so glad she won Grammys last night. Okay, are you guys ready to learn about terpenoid molecules? Did I get your attention? Did I get your attention? Did I get your attention? What's that? Boom mic, boom mic, boom mic. Did I get your attention? Are you guys ready? All right, let me get this up and going. Crossover. I actually have something working here. Yay. I was trying to get this to work earlier. So, I'm on the big monitor though. Okay, so I told you we were going to be going over terpenoid molecules, and did I get your attention when I came in? You know, I really wanted to have the music going, but I don't want to have a copyright strike. So, anyway, and I wanted to play with my beats, which were pretty cool. Okay, so terpenoid molecules is what we're going to go over because we want to learn about the constituents of essential oils. Okay, now I have my little slideshow, but I don't know how to get it to where like it's a real slideshow. Let's see, slideshow from the beginning. Oh, wait a minute, it's taking over the whole screen. Hold on. Oops. Oops. Hold on, y'all. I'm coming back. Oh, cool. That must be the talking thing that comes with the computer. But let me figure this out here. Wait a minute. Okay. The purity of oils. Swap presenter view and slideshow. I'm like so confused. Sorry. That's me. Okay, so why do we want to know? If you can see my little screen in here, I hope you can. I can make it bigger. Okay. The purity of oils. It's the chemistry of essential oil that helps indicate if our essential oil is adulterated and contains solvents. That's really why we want to know and learn about essential oils and how to determine the constituents or compounds to figure out how to properly blend. And also we want to make sure that, like with my spectrometer, you know, I can do some things with it, not like the big machines that they have now, like the giant machines, but I can use some old technology and still kind of do the same thing. But it just doesn't break it down. I can see, like if I know if one essential oil is very pure, I can use that as my test subject. And then I could put in another one that I know is not, and I can it'll show me where it's off. But okay. But we want to make sure that there is no propylene or glycol or petrochemicals that have been added to our essential oils. Because like for me and in my business, I'm working with extracts as well. Okay. And we know essential oils are kind of volatile. And basically, you know what that means, it's just, it loses the scent after a while, okay? So the chemistry analysis of essential oils will show if the plant has a chemotype in it. And I thought I would just break this down. An essential oil chemotype is derived from a plant that has the same visual appearance and characteristics. Okay? So it has the same visual appearance and characteristics, but it is chemically composed of differing components. Now, if you guys remember the whole bee thing, when I was going over the tattoo salve, it really depends on the region of where that plant is grown. Okay? So the essential oil chemotype has different therapeutic properties due to the presence of different chemical compounds or constituents. Okay? The individual chemical constituents or compounds can identify the medicinal properties of the oil. That's why it's important. When blending or mixing essential oils, you must have, literally, you must have some knowledge of the properties of essential oils and the individual constituents or compounds of them. You just can't start throwing stuff together. Like, let's say, for instance, you really like the smell of peppermint, and you decide to make your own blush, or you even put it in your mascara that you're making or something. It's really going to burn. It's going to be highly unpleasant. Okay? And that's why we want to learn what the chemical constituents are in each essential oil that we use. So then we'll know, okay, this is something that's good for this, but not for that type of thing, okay? Now, so we're going to break it down. We're going to go into terpenoid molecules. Go over here. Okay, terpenoid. It's any class of compounds that are characterized by an isoprenoid structure like that of terpene hydrocarbons. An isoprenoid are made up of isoprene molecules, basically, okay? So each isoprene molecule, sometimes called an isoprene unit, contains 5 carbon atoms with double bonds. Terpene, any of various isomeric hydrocarbons. It's like C10H16, which is like a whole class of things. Found present in essential oils. So it's like terpenes, the largest single class. Like I said, it's a large class. So what that means is there's many different constituents. But it's the largest single class of compounds actually found in essential oils, also called isoprenoids. Now, hydrocarbon, that's what C10H16 is, okay? H is for hydrogen, C is for carbon, okay? Hydrocarbons, they're any of a class of compounds containing only hydrogen and carbon. Hydrocarbon, okay? So C is for carbon, and H is for hydrogen. Where does this information come from? What's that? What's that? The periodic table of elements? That's true. Good job. That's why we have to have that. Okay? So the hydrocarbons are really important. So when we want to go ahead and learn what's in our essential oils. Okay? So we know the largest compound in essential oil is terpene, and they have a large it's a huge class of compounds, okay, of hydrocarbons. Now, I told you that I would get over, I'm getting ahead of myself. So what did I just say? What was I just talking about? Let's break it down even further, okay? A chemical compound is a chemical substance composed of many identical molecules, composed of atoms from one or more than one element held together by chemical bonds. Okay? An atom. Let's just break it down even further. Okay. An atom is the smallest particle of an element, still having the same chemical properties of the element. So, an atom is the smallest particle of an element, still having the same chemical properties of that element. There are over 100 different kinds of atoms. By combining these atoms in different ways, we can pretty much make anything in the universe. Anything. Atoms are so tiny that they can't be seen, even with the most powerful microscope. Even though protons and neutrons, okay, it's all part of the atom, make up the nucleus of an atom. I know this is kind of elementary. However, this is for everybody, okay? On up, all right? Most of the nucleus is empty space, okay? So we know, atoms have protons and neutrons. They make up the nucleus of the atom, which is like the center part, which is mostly empty space, all right? So molecules are formed. Molecules are formed when atoms are combined. Atom, molecule. Okay? Does that help? A little bit. I'm trying to simplify this, okay? Now, I told you I'm going to go over the head to tail rule, which kind of simplifies things even further. Okay? This rule states that terpenes are formed in the head to tail formation from isoprene units. Okay? Can you see the formations on the little PowerPoint thing that I put together? You can see okay, so you can see here the head, okay, and to the tail. Okay, and then here's another example of one right there. All right. Now, these have the hydrocarbons C5H8. But now, this is the kind of like, do I really need to have this knowledge? Isoprene is really not found in plants. Essential oils are from plants. But they're also from rhizomes. What are rhizomes? Like roots and things? But they also, so isoprene is not found in plants, but serves as a simple aid, a visual aid to remember the structural formation. And that's really what we want. Because when we start getting into really the chemistry of it, we can put together, okay, the chemical compounds, and then we can start putting all of those compounds together of different essential oils. We can put them, we can layer them on top of each other, and then we can see the synergy effect. Okay, that's what's so exciting, is the synergy. And that's what, I'm trying to convey and trying to teach, is that, okay, terpenoid molecules, basically, the compounds of the essential oils, the constituents of essential oils. Okay, and then they're broken down into different classes, okay? And I went into those in our basic overview. And so our next little thing is going to be over the first one, which is like monos, I think. I'm being bad. Hold on. I forgot. Because I'm thinking about, okay. All kinds of good stuff here. Oh, okay. So we're going to go into the hermatopenes, which actually have one unit. It's going to be our next, because terpenes are classified as hermatopenes, which have one unit, monoterpenes, which have two units, okay, this was what I had a hard time with last time. Sesquiterpenes have 3 units. Diterpenes have 4 units, and Cysterpenes have 5 units. Triterpenes have 6. And polyterpenes, thank you for an easy one, polyterpenes have many units, okay? So it's exciting because, see, it's the combination of two isoprene units are called a terpene unit. So it's, I think it's kind of exciting. So I hope you do too, because we want to know, how to blend essential oils and things to where we can use the fewest amount of oils and still get that big bang effect. Okay, so my next little thing, hopefully I'll be able to do the slideshow a little bit better, but I'm learning. And thank you to my husband. High five for my new computer. And I'm using my son's big monitor. I have it attached, which he'll be getting back, I'm sure, when he comes back, unfortunately. But hermoterpenes have 1 unit. Remember that. We're going to go over that next. So, Julie with saltmixology. saltmixologyrocks@gmail.com. We're doing a little essential oil chem. Just a little. But you may think it's basic, and another may think, wow, okay, what? So I'm going to try to figure out how to put this information in the information underneath the video. If not, I'll just be putting the wording in there. But email me at saltmixologyrocks@gmail.com, and I will send you my little PowerPoint presentation with really just 4 slides and a title. But even just going to the basic atom, that's where it really all starts. Okay, because atom, and then it forms compounds, and there could be just like hundreds of different kinds of compounds. So, when I came in here, I was thinking about speech 101 when I was in college with our professor. She came in with the boombox. This is way, way, way beyond boombox days, okay? Because, I got my degree later in life. But she came in there, and she was playing music and dancing, and she got our attention. So even though you couldn't hear my music, I sure hope you knew what I was dancing to, because she won like a woohoo amount of Grammys last night. So anyway, danced to her before. But everyone have a great day. It's Julie with saltmixology. Boom mic, boom mic, boom mic. Head to tail rule. Learn it. It'll be a lot easier when we start putting stuff together. Okay? You want to know about synergy. All right? And I think, what? We'll do the herpiterpene, and then I think we should go over my favorite essential oil, which is lavender. But we'll see. I want to keep it as simple as possible. But y'all have a great day. It's Monday, 1/27/2020, and it's 6-ish Central Standard Time. Bye.